Hello students, today we are going to solve very important example in Maxima and Minima, and some students have demanded to solve a few more examples on Maxima and Minima. So this is I have example 3 and example 4. If you see x, y, z are the angles of triangle, find the maximum value of cos x, cos y, cos z. And next example I'm going to solve example 4, find the maximum value of the function sin x into sin y into sin x plus y, where x is between 0 and pi by 2 and y is between 0 and pi by 2. So like this we have two examples I'm going to solve. So before solving this example, students, please you should remember that in my last video we have discussed working method for maximum and minimum. Yes students, we see maximum and minimum method very simple. Let f of xy be a given function. Step 1, we go with steps. Find dou f upon dou x and dou f upon dou y. Differentiate with respect to x partially, keeping y constant. And here we have differentiating f partially with respect to y, keeping x constant. So partial differentiation I have already done one video. Please watch that video so you can understand very easily maximum and minimum. Then next we'll just solve, taking this function must be equal to 0 and this function must be equal to 0. Simultaneously we get the points. So when we select the points, students, we can see in the step 3 we'll find out a, b and c, where a is equal to dou square f upon dou x square, b is equal to dou square f upon dou x, dou y, c is equal to dou square f upon dou y square, and we are going to calculate this a, b, c for each points. Then in step 4, if the points x1, y1 we have ac minus b square is greater than 0 and a is less than 0, then the function is maxima, or the pair what we get, the value of f of x1, y1 is the maximum value. Is it clear, students? So next, if the points x1, y1, if ac minus b square is greater than 0 and a is also greater than 0, then f of xy is a maxima for this pair, and the minimum value is f of x1. If ac minus b square is does not less than 0 or greater than 0 for point x1, y1, then there exists neither maxima nor minimum of f of x. In this case, f of xy is said to have a saddle at x1, y1, saddle point at x1, y1. So you may get sometimes in the exam that is ac minus b square less than 0, or it is ac minus b square is equal to 0. So then in such cases we say it is saddle point, or neither it is maximum nor it is minimum. So like this we have to remember the steps. Now we will go to the example, students. In my last video I have discussed this example, please watch that video. And even I have solved the one more example, this function. So today's class I am going to solve these two examples. So easily you can simplify this example one by one. So first we will take angles x, y, z, angles of triangle. So find the maximum value of cos x into cos y into cos z. Yes students, you can see I have made all the semester's video, and you can easily find all the notes in the description box. Before solving this, please I request all the students that in this video we see very important examples for exam point of view. Please watch the video till the end. If this video is helpful for your exam, please like my video, share and subscribe the channel, link given below in the description box. It will motivate me for next video. Thank you so much for watching my video till the end. Notes will be uploaded in the description box. Please watch other videos given in the description box. I have made different playlists for different topics on my channel. I have made all the semester videos and notes which you can download it freely. Only I ask for likes, share and subscribe my YouTube channel, Engineering Mathematics Made Easy for All. So immediately we're going to solve the example here, students. Suppose if I take this as if x, y, z are the angles, one can easily see in a triangle all the three angles will be always equal to 180. So this I am going to write it in the radian form. So therefore all the angles are x plus y plus z must be always pi, that is 180 degrees. So always we take the function f of xy. So I'll just make the changes so that I say that z must be then in this case minus x plus y, so that our maximum and minimum function will become very easy. So thus if I take z is equal to pi minus x plus y, then I can write the function. I want the function must be in always function of x comma y. You can see in my working rule I have given the function must be only x, y. So therefore it must be maxima and minima. Therefore, so I say this function whatever is given in the question, I'll take that as cos x, cos y, cos z, which is equal to, I'm just substitute z in this equation and I will write the function in terms of f of x comma y. So here I have pi minus, I'm just substituting z value. Then we simplify this. You can see pi minus x plus y is always, you can see cos of pi minus theta, the angle if you take it will become always minus cos theta. So therefore I'll write this as minus cos x cos y cos x plus y. So please remember minus I have taken this side. So I'll say that take, now I'm going to take for our function to be maxima or minima, I'm going to take this as function f of x. Please remember this step 1 students, we already discussed step 1. So it is fx must be 0, fx is nothing but dou f upon dou x I have to find, right? And similarly I'm going to find simultaneously it is fy, which is dou f upon dou y. Please remember by using partial differentiation we are going to simplify this. Remember that already we have studied partial differential equation, that is more important. So I will take this function now, differentiate this function with respect to equation 1 and let me take equation 1. I'm going to differentiate with respect to x keeping y constant. So therefore I get this as fx is equal to, so first cos y, if I take out constant, this value if I take out constant, we can easily say that this will become our u into v function, u into v function I will get here students. Okay, so when we get u into v, then we'll differentiate this. First I will keep v as it is, differentiate u. So here please remember I am differentiating with respect to x. So cos y is constant, I will take it outside. Differentiation of cos x will be sin x, so it will be minus sin x. I will write here minus sin x, and I will keep cos x plus y as it is, no change. Then plus, now I will differentiate cos x plus y. I will keep cos x as it is, no change in cos x. I will just differentiate cos x plus y. It is going to become minus sin x plus y. So please remember here students, minus if I take outside, this minus and this minus will take it outside, so it will become plus, minus into minus will become plus, minus sign I have taken outside. So therefore we get this function as cos y sin x cos x plus y plus cos x sin x plus y. This is clear students. Okay, now you can see very easily that this is going to give you sin a cos b. So this will be sin a cos b plus cos a sin b. So we can easily find out this must be equal to sin a plus b. When this is sin a plus b students, we can easily find that what is a, it is x, and what is b, x plus y. So we can say that sin a plus b, so what will be a plus b, it is x plus y, or we just write it as 2x plus y. So this is our a plus b. So therefore we know that, yes students, we know that this things, therefore I will directly take fx is equal to cos y, no change as it is I have written, only I'm going to write sin a plus b, that is sin 2x plus y. So this is our fx. Similarly I'm going to do for f of y. So here I have to simplify for fy. So I will write it in the next line. So take now fy. So we know here it is dou f upon dou y, which is equal to, now here I am going to take x constant, so cos x I will keep it as it is. So there will be, so I'll try to write it here, but it will take time. Okay, cos x is constant, so please remember this is going to become now constant, so minus cos x, I will take it outside. I'm going to take this as, now in this case I'm going to take u, and this is going to be v. Okay, so this is going to be u now, and this is going to be v. So now I will differentiate this. Now I will keep minus cos x as it is. Now differentiate cos y, it will become minus sin y. I will keep v as it is, that is cos x plus y as it is. I will keep, no change. The next I'm going to keep now cos x as it is, so it will be, sorry, cos y as it is. I'm going to keep, differentiate cos x plus y, it will become minus sin x plus y. So this is what we get, the differentiation partially with respect to y. So again here minus, and this minus will become plus. I will take out minus outside. So what will remain here, students? It is cos x in the bracket sin y cos x plus y plus cos y sin x plus y will be done. So please remember what we know the formula here, students. If you remember the formula, we know that, what we know, yes, it is again sin a, this is going to become cos b plus cos a sin b, which is equal to sin a plus b. So we know that a plus b, now what is a? It is y, plus what is b? X plus y. So that will give you x plus 2y. So we know this, we know this part here, friends. Is it clear? So we are going to substitute. So therefore please remember now, fy will give you cos x, and this will be sin x plus 2y. So this is what we have got, the substitution. So please remember here, but we know that by taking the step 2, we are going to take the function here. In the step 2, we see fx must be 0 and fy must be 0. When this is 0, yes friends, when this is 0, so please remember which value it will become 0. Go on substituting pi by 2, then pi by 3, all these values if you substitute, you can easily find both these equations must be 0. So therefore we take it as, when this is possible, only when x is equal to y is equal to, it is pi by 3. I'll show it in the calculator. Yes, you can see here calculator in the right hand side, students, that how sin x plus 2y is 0. So both must be pi by 3, and it is, the value is 0. You can see in the calculator. You can try it. Now we know the point. We got the point, that is pi by 3, x and y. So immediately we'll go to step 3. That is, I'm going to find a, b and c. Okay, so let us find a, b, c quickly. So a is equal to, we know that a is equal to fxx, which is equal to dou square f upon dou x square. I'm going to differentiate this 2 times, keeping y as constant. So just now we have done x. So it is, here you can see cos y is constant. Only have to differentiate sin 2x plus y. So please remember here, differentiation of sin 2x plus y. We will get this as constant. I will take it outside. So 2 I will take it outside. Sin differentiation is cos. So it will become 2 cos 2x plus y. Similarly, if I differentiate this fy with respect to y, so if I take dou upon dou y, please remember here cos x will become constant. Only I am going to differentiate sin x plus 2y. So sin will become cos, but here constant 2, I will take it outside, will become 2 cos x plus 2y. So this formula I have given on the right hand side, we are going to use in this a. So therefore the differentiation will become 2 cos y. Cos y is constant, so I will write as it is. Only sin 2x plus y will become, sin 2x plus y will become 2 cos 2x plus y. Similarly, if you take C is equal to, we have taken Fyy, which is equal to dou square f upon dou y square. Similarly, here we get cos x constant, so I will write cos x as it is, and differentiation of sin x plus 2y will give you 2 cos x plus 2y. Just now we have done here. Sin x plus 2y will give you 2 cos x plus 2y. I have written here, so we get this as A and C. Okay, now I have to find out value of B. So B will be f of xy, which is equal to dou square f upon dou x dou y, which I can take it as dou upon dou x, and this is dou f upon dou y. We know what is dou f upon dou y, so just I will show you. So here we have dou f upon dou y, so I will substitute that value. So dou f upon dou y is cos x into sin x plus 2y. This is what we have. We have to differentiate this ones now with respect to x. Please remember, here we are going to keep y constant. This is partial differentiation. Before watching this video, please watch my previous video on partial differentiation. You will come to know how we are going to differentiate this now. Okay, let us differentiate this quickly. So now I will keep I will give u into v. I will take this as u into v. This will give you, first I will give u as it is, cos x. Differentiation of sin is going to become cos x plus 2y plus, now I will keep sin x plus 2y as it is. Differentiation of cos x will become minus sin x. So therefore b must be equal to cos x plus 2y minus sin x plus 2y sin x. We know that cos a cos b minus sin a sin b must be equal to, so take sin must be equal to cos a plus b. So therefore we can say a must be x and b must be x plus 2y. If you take a plus b, it will become 2x plus 2y. So therefore I say that this b must be equal to, so we'll take this, we know that. So we know that this formulas. So therefore we get b is equal to cos 2x plus 2y. So this is how we have calculated the ABC. Now we see for, we have taken already the point xy is equal to pi by 3. Just substitute this point in ABC. You can see in the calculator here, students, very easily. Substitute all the values in the calculator. On right hand side, I'm going to show the calculator. Please use the calculator and see what is a equal to. Yes, a is equal to 2 cos pi by 3 into cos 2 pi upon 3 plus 1. You can just very easily, you can get it is minus 1. Similarly, you try for b, it is minus 1 by 2, and c is equal to minus 1. Just substitute in the calculator. They will check now what is the condition. Therefore, we can see AC minus b square. What is AC minus b square? A is minus 1, C is minus 1, minus 1 by 2 square. So put it in calculator here, students. You will get this is equal to 3 by 4. So that implies it is positive value, means it is greater than 0. Easily you can see, check what is A. Here we can see easily a is less than 0. Yes friends, use the condition now. Step 3. Therefore f of x comma y is maxima. Now we have to find maximum value. So to find maximum value, immediately you take the z value. Therefore since z is equal to pi minus x plus y, we have when z is equal to pi by 3. How this is happening students? Because as we have taken x is equal to y is equal to, that is pi by 3, automatically we can say that this z must be pi by 3. Therefore x, y, z are equal. Then we can easily make out that z is equal to pi by 3. Thus here students, the final answer, that is maximum value, we are going to find out. What is the maximum value? Yes, maximum value of, therefore maximum value of cos x function, what is given in the question, that I am taking down. And this is because when x is equal to y is equal to z is equal to, it is pi by 3. So therefore this is cos pi by 3, and this is going to give you the maximum value. So therefore this must be cos cube pi by 3. So that implies this is possible when it is 1 by 8. So this must be 1 by 2 into 1 by 2 into 1 by 2. You can do it in calculator. I have shown in the right hand side here student. Easily you can find out what is cos pi by 3, and therefore this is our maximum value. Yes students, stay tuned to the end of this video lecture. Next, immediately I am going to solve the next example. Very, very important students, examination point of view. Here we can easily find maximum value of the function x into sin y into sin x plus y. Write down the solution and simplify, where x must be in between 0 and pi by 2, y must be in between 0 and pi by 2. Similarly, you can see they have already given the range. So x is tending from where and y is tending from which direction to which direction. So find the value of f of x, f of y. So here we are going to take the solution. So you can say sin x into sin y into sin x plus y we have. So step 1, we follow the step 1. You can see step 1, we are going to find out, I will take the function fx. So let this function be, take f is equal to sin x, sin y and sin x plus y. So they are in the multiplication. So I will just take fx. So I think everybody know fx is dou f upon dou x. So this will be equal to sin y and sin x. So please remember I am going to differentiate with respect to x. So y is constant. So sin y is constant. So I have taken out sin y outside. So when I take sin y outside, I will take this as u and this is v. So u I have kept as it is. Differentiation of sin x plus y, I will get this as cos x plus y plus. Now I will keep sin x plus y as it is. Differentiation of sin x I am going to do, that is cos x, and sin x plus y as it is. So now I will find the fx plus y. So here we can see students very easily. This is sin a cos b plus cos a, and this is sin b. So I think everybody knows that this formula in my previous example also I have given. This is sin a plus b. So you can see using this formula, just take this. So using this formula we know that, so I'll just see a is x and b is x plus y. So that implies this formula you will get this as sin x plus y. So therefore it will become sin 2x plus y. So this I am going to substitute in the above equation. Though here you can see very easily students that fx will be equal to sin y, no change, and here I get this is sin 2x plus y. So like this we find fx. Immediately I have to find now fy in first step only. So I'm going to differentiate this with respect to y, keeping x constant. Okay, I'll take out first sin x outside. So easily one can identify that which is u and which is v. So let me take this as u and this is v. So I will keep first sine y as it is, and I will differentiate with respect to y. So it will become cos x plus y. Then this is plus. Now I'm going to differentiate here u. So it is sine y is u. Differentiation of sine y will be cos y, and then I will keep sine x plus y as it is. Plus y. I think you have come across already here, students, that u into v, u as it is, differentiate v with respect to x plus differentiate u with respect to x, keeping v constant. So this formula I'm going to use every time. So now immediately remember this, students, the formula will be here now. Again, this is sine a cos b plus cos a sine b. So this is equal to sine a plus b. This formula I'm going to use here, students. So now here it will be a is y we have taken, and b I'm going to take this as x plus y. So I will get this as sine a plus b will become now sine y plus x plus y, and which is equal to sine x plus 2y. So like this I have simplified dou of m dou y, and just substitute this value here, students, in the fy. So therefore I get this as fy is equal to sine x is constant, so I'll write as it is, and I'll get this as now sine x plus 2y. Yes, friends, if you don't understand, please rewind this video again and again till you understand, and write it in the book and practice the examples again and again. You will come to understand. So now I'm going to find the point now here quickly. So you can see, since the given question, you can see very easily that the x varies from 0 to pi by 2 and y varies from 0 to pi by 2. So means x and y must be in this condition, in this range only. But we know that in first step I'm going to find fx is equal to 0 and fy is equal to 0, and I see that in this point only it must be satisfies this condition. So if I just identify that what must be the angle, so it is pi by 2 is in radian. So if I make this 0, sine y will be 0 and sine 2x plus y must be also 0 to make fx 0. So what must be that value, so that easily I can make this terms 0. Okay, so I'm going to take the angle other than 0. Please remember, 0 must not be the angle. 0 is less than, so 1 2 3 4 like this, but not 0. It is x is the range from between 0 and pi by 2, but not 0 and pi by 2. So that angle you have to find out and make this. You can just see in my calculator on the right hand side. I will just see what is sine all the angles, and easily you can identify that this is possible only if x is equal to y is equal to pi by 3. I think last example also we have got the same thing. So therefore, thus we say that thus only by x pi by 3 and y pi by 3 point is the possible condition. So what is it? So this is possible only when the condition satisfies fx is equal to 0 and fy is equal to 0. So now this is done. Now I'm going to go over step 2. In step 2, please remember this, friends, I have to find a, b and c. Okay, let us find a, b, c quickly. Easily we can find a, b, c. So I will take this as a is equal to dou square f upon dou x square, so which is equal to, I think already we have calculated fx. Here you can see on the screen sine y into sine 2x plus y. So I will just substitute here. It is sine y into sine 2x plus y. So I am writing all the steps around so you can understand very easily. So this is equal to, I am going to differentiate with respect to x. So sine y I will write it as it is. Only I am going to differentiate sine 2x plus y. So therefore, please remember this formula here, students. And whenever we differentiate with respect to x, keeping y constant, in such cases we get this as chain rule. It will become cos 2x plus, so I'll just take this in. So it will be cos 2x plus y into inner differentiation, it will be 2. So like this we get this as 2 cos 2x plus y. So I will take here 2 and I will write here cos 2x plus y. Is it clear? So like this we can easily find the value of a. Similarly, I will find the value of b now. So what will be the value of b? B must be equal to, it is dou square f upon dou x dou y. So please remember this means that whenever we take this differentiation substitute in this way, it is actually differentiation of x, and this is dou f and dou y. So already we have calculated dou f upon dou y, so please substitute that value. It is sin x plus 2y. So please remember that when you're differentiating with respect to x, I will take this now u and v rule. Okay, so let us take u and v rule. What we will get, we can see here. So I will first remember the formula, students. Every time, no need to tell you again and again. U I will keep it as it is, differentiate with respect to v, plus u I'm going to differentiate, v I'm going to keep it as it is. So I'm going to keep u as it is, sin x I will keep it as it is, differentiation of cos sin x plus 2y will become cos x plus 2y. Again, using chain rule, you can see very easily that one I will get it because x is there. So plus now I'm going to differentiate cos x. I will get here cos x, differentiation of sin x is cos x, and then I will keep sin x plus 2y as it is. So therefore, now again, please remember this, runs. What is the formula I'm going to take here? Yes, it is sin a cos b plus cos a sin b. Here very easily you can see here, friends, it is sin a plus b. So what I'm going to take? I'm going to take x as a, and b I'm going to take here x plus 2y. So what will be sin a plus b? So I'm going to take right here sin x plus b is x plus 2y. So if you simplify this, it will become sin 2x plus 2y. Okay, so I'm going to substitute this in the formula. So therefore, I'm going to substitute this. We know that. So we know that this is the formula. Okay, so let me substitute in the above equation. So therefore, I get this b is equal to sin 2x plus 2y. This is how we are going to find b value. Immediately you have to find the c value. What is CR3, students? It is dou square f upon dou y square. So please remember what is dou f upon dou y. I'm going to substitute the value here. So it is sin x plus 2y. So I'm just substituted dou f upon dou y value. Okay, so this is equal to please remember, when you're differentiating with respect to y, x will remain constant. So I'll write here x outside, so that is actually sin x. I will just differentiate sin x plus 2y, so it will give you cos x plus 2y. Again, chain rule, using chain rule I will get into 2. So please remember this, friends, the formula, that always whenever you're differentiating with respect to y, sin x plus 2y will become cos x plus 2y into dou 2y divided by dou y. So 2y will take it outside, dou y will get cancelled, it will become 2 cos x plus 2y. So therefore, I'll substitute this in the equation. So c is 2 into sin x cos x plus 2y. So like this, you can simplify the values. Now immediately substitute in the formula. So I will get this value here, friends, ABC. I'm going to substitute the points so that I can find the condition. So at pi by 3 at point, so A is equal to, so substitute the values here, friends. You can see in the calculator. So you'll get this as root 3. Now I can find B. Just see in the calculator. On the right hand side, you will get this as B is equal to minus root 3 upon 2. Similarly, C is equal to, you can see in the calculator, it is minus 3. And now I am going to simplify in this condition, that is AC minus B square, which is equal to 9 by 4. You can do it in calculator. You can just see it is always greater than 0. And please remember here A. What is A? A is less than 0. Therefore, we say f of x comma y is maxima. So if the function is maxima, you have to find the maximum value. So therefore, maximum value is fxy is equal to, so you can substitute in the calculator and see the value we get here. This is 3 root 3 divided by 8. You can just check in the calculator. So if this video is helpful students, please like and subscribe. Thank you so much watching the video till the end.